Hi, thought I'd do a quick video on how to do a kludge or a bodge. What that means is cutting and hacking a circuit board to correct an error that was made on the board. And it's this circuit board here. The brilliant engineer that designed this board made a mistake and didn't find the mistake before he laid it out. And now I'm going to have to fix it. But that brilliant engineer shall remain nameless and therefore blameless. But anyways, this will be a quick video on how to put some components on the back side of the board to correct an error on the front side. So the first thing I did was I printed out the schematic and then drew on it the correction. And in here, well, first of all, here's the correct circuit the way it should have been. This is the way it is. These two circuits here are identical, and so they're both going to get changed. I just drew it on one of them, but it should have been this. And so I just printed out the schematic, drew the correction here, figured out the values of the resistors that I needed, and then drew it in, showing where I'd have to cut the traces and put the components into the proper place on the circuit board. Now the next thing I did was I printed out a copy of the layout like this, the circuit board layout. So the board is oriented this way, or it's actually backwards. This is the way it's supposed to be. So I printed it out, but I mirrored it so this is what you see on the bottom side of the circuit board, and this area here and this area here is where the kludges are going to be done. And then I draw with red pen or felt pen what traces I'd have to cut, like this one here. And maybe I'll just zoom in a bit. Gotta find the zoom button. So I show that I cut this trace here, and then I cut this trace up here, and then this is a transistor that's got to be added, a resistor, and another resistor, and I'm just showing where everything gets connected to, and then I'll have to run another trace between these two connections here. But you take the circuit board layout and the circuit board and you trace the circuit out on the board, and you have to flip it back and forth to look at where the components are on this side and figure out what pin is what, and then go back to this side again and keep going back and forth until you get exactly what pins you want to cut, and also the layout that you want to do. And I did this without having to add any lengths of wire to the transistor or the resistors. I just used the lead links that I had, and so I was able to make it small enough, and then when I was finished I just glued it down. So that's the planning stage. So I work it all out, how I'm going to do this, how I'm going to lay it out, and it might take several sheets of this paper. You might have to print it out more than once to come up with the best layout. And when you finally come up with it and you're satisfied with it, then you start doing the cutting and hacking on the board. The first thing that I'm going to do is I've got to cut some traces, and when I figured out what traces to cut, I went in with a felt pen, and you can see the black marks on the board here showing where I'm going to cut it, or cut those traces. Now you can use a knife like a box cutter or a scalpel or something sharp to cut the traces, and you cut the trace. The best way to do this, if you can use a knife, is don't just cut it in one spot. Cut it in two spots close together, and then scrape out the piece of trace in between the two cuts that you've made. The thing about a knife is it can slip, and if you've got traces close by, you can cut them as well accidentally. So what I prefer to use is a rotary tool, something like this guy here. This is Canadian Tire's version of a Dremel, but it works pretty good. And I got one of these little burr bits here that are good for just grinding off the traces. And then you just go at it very carefully, just grind off just enough to get the track off the board. Well, let's see what we did here. All covered with dust. So I've got my components together now, the transistors and all the resistors I need, And a couple of the important tools you're going to need is, first of all, a really good soldering iron like this. Mine's temperature controlled. I can adjust the temperature on it. I've got, I'm using a sponge here. I won't show it to you, but a damp sponge for keeping the tip clean. And of course a spool of solder. And the best kind of solder to use for this kind of work is, if I can get it undone, but anyways, it's a very fine solder. I'm not sure what it is. 0.8 millimeter diameter. You can even get smaller diameter solder than this. It depends what you're doing, but this, for me, for through-hole stuff, this works pretty good. There we go, got the free end. And indispensable tools, a good pair of needle nose pliers. I've had these things for years and they're really good for me. And I use them because I can easily bend loops and bend these leads around to get them to fit the board properly. And then a good pair of flush cutters or side cutters so you can trim your components. So when you're going at it, you've got to figure out how you're going to do this, and I usually start with the looser components. Like this is a resistor here. I'm not sure how well it shows up in the video. So I'm going to put that resistor down first, and it's going to go onto which pad here? This pad right here. And it's going to go off in that direction, and then I'll put the transistor in there and solder the two leads of the transistor, or the base of the transistor, to that resistor, and that way I'll keep the transistor in place, and then I can start putting in all the other components. So I've prepared one end of this resistor, and it's going to go on that pad right there. And I don't know if you can see it very clearly, but you can see the loop in this direction, and then when I turn it to the side, you can see how I've bent the loop down so that it's flush with the body of the resistor. So I've done that because I know that the resistor is going to sit flush on the board, and I've got to bend the lead down a bit to make the loop actually go around the pad right there. The next thing I'll do is I'll put some fresh solder onto the pad and then stick the resistor down onto the pad. Maybe I'll just leave the camera going for this and see how it works. Not sure if my head's getting into the picture or not. And all I want to do is just tack it into place like that, and just to get it in place, and I'll come back and tidy up. Actually, I'm not really happy with that. Let's try it again. What can help too is clean the tip of the iron off and put some fresh solder on. So you got a bit of a blob of solder on the tip. I don't know if you can see that. And then use that to melt down onto the pad and the lead. That's better. So I don't know how clear that is, but you can see how I filled in the loop of wire of the resistor with solder. And then I'm just going to clip off the end of it, this last little bit. Tidy it up, and that's good for the first part. Now the transistor is going to go in like this. You can see that clearly, and then the center lead of the transistor, which is the base, is going to be soldered up really close to the body of the resistor, kind of like that. Is that a better view? Yeah. So, and then that'll give me the most lead length that I can get away with on the transistor. So the next thing I'll do is just trim off the excess lead of the resistor here. I don't need very much to solder the transistor to it. And just bend it over. And then I'll take the transistor and I will spread the leads out. It's an odd angle here. The camera's looking from a different angle than I'm looking, so I'm going to turn it towards me to see what I'm doing, and then the camera's not going to see it. So I'll splay those leads out a bit because I know they're going to go somewhere else. And then I'm just going to gently trim off the excess of the center lead here. Like that. And then we'll stick it on. And this is a bit tricky, and I'll probably have to use a pair of pliers so I don't burn my fingers. first thing I'll do is put some solder on the lead just to clean it up, and then I'll get a bit of fresh solder on the tip of the iron. Let's see if I can do this without burning myself. Now I know the orientation of the transistor. It's actually written on the transistor what the leads are. This is the emitter, the base is in the middle, and the collector's on the side. So on the other side. So I just have to flip it over because I want the emitter over here because it's going to this part of the board. And it's not quite where I want it. A quick little, yeah, I waited too long. If you put solder on the tip of the iron and then you wait too long, the solder gets kind of gooey and sticky and crystalline. It doesn't flow very well. So you got to be quick. There. All I've done is just tacked it on. I don't really care too much about how good the joint is. I've just got it in place, and it's exactly where I want it. Now the next thing I got to do is I've got to put that wire onto this trace here. And now the trace has got solder mask over it, so I can't solder to it. So I'm going to have to scrape solder mask off. And this is where something like this, a box cutter, I use it quite a lot for electronic work, is these box cutters. They're cheap, and the blades are replaceable. And I'll just go in here and gently scrape the solder mask off the trace. You got to be gentle here though. You want to make sure you just scrape off the solder mask and not the trace as well. You don't need a whole lot, but you need enough there, enough of the trace clear so you can get some solder on it. I wouldn't use the Dremel tool for that because you'll end up in just grinding off the trace. So I've got most of the solder mask off, and then I'm going to tin that little spot to make it easier to solder. Tinning means just putting a bit of solder on it. Like this. And then bend the lead of the transistor over onto that pad. And use your pliers for that. This is what needle nose pliers are for. You've got to hold the transistor down and then carefully bend it, not too close to the body of the transistor because you can actually break the lead off inside the transistor, or right at the base of the transistor, or right at the body of the transistor there, and then you'll have a hell of a time because you won't be able to attach anything to it, and you'll have to get another transistor. We just keep bending it, twisting it until you get it where you want it. And then I'm going to trim off the excess lead here. Maybe leave a little extra lead just in case. And then looks like I'll have to bend it a bit more to get it in the right spot. Oops, there we go. And then I notice that it's not sitting on the board on the trace, so I'll just give everything a bit of a twist and push it down. And that's pretty good. And with the tin already on, or the solder already on the trace, it makes it quite easy to solder it. It's not wanting to solder very well. There we go. Okay, so there's the first two connections. Is the camera going to focus? Yeah. And I'm well on my way to getting this thing put together. The this lead of the transistor has to end up going over to this pad here. So I'm just going to bend it over top of that resistor and solder it to that pad. And because it's sticking out a bit, I'm going to put a piece of heat shrink over it and then bend it over and cut it to the right length and solder it to that pad. And then the next resistor will go right in here like that, and it connects to the same position, the same place as the other resistor. And then I'll put a piece of heat shrink on it as well where it goes between those two leads, and then I'll bend the upper lead over towards the other end of the transistor to where it's supposed to go. So I'm going to do all of this next bit off camera because first of all it's probably pretty boring to watch, and secondly I need to concentrate on what I'm doing and I got to get closer to it, and I'll just be getting in the way of the camera. Something I forgot to mention as well is part of the changes here that I'm making. This resistor here, this one here, and this one and that one, both these resistors have to change as well. The value is going to be different. Now to get them out of the board I could stick a soldering iron on the back and pry them out, but resistors are cheap, less than a penny each. This is the way you do it. You cut them out and then solder suck the rest of the lead out of that hole. And that's the quickest way to deal with changing a resistor on the board. You don't want to work these holes too hard, and the through plating isn't very thick, and you could damage it or pull it out, and then you'll have trouble if there's a connection on the top and the bottom of the circuit board with that particular lead. And even if there isn't one, most of this particular design, there are very few connections on the very top. This is just a ground plane, and neither of these resistors connect to the ground plane. All of the connections are on the bottom side of the board, so even if I pulled the through hole plating out, I'd still be able to solder, just pull the lead out and then bend it over and solder it to the trace or something like that. But I'd rather not have to do that, so I'll clip the resistor like I've shown you here, and then I'll just pop it out with the solder sucker. In fact, cut the rest of the resistor off. Now the most effective way to solder suck out these holes is to put the, this is just one of these regular, where are we here, spring-loaded solder suckers you can get at hobbyist stores. I don't have the finances to be able to buy a good pump type solder sucker or desoldering tool. Maybe someday I'll buy them. They're coming down in price. So I bought this thing here, and I find it's quite effective if you use a few tricks. And one of the tricks I'm going to use here is I'll put the solder sucker on one side of the board and heat the pad on the other side of the board, and you can suck it straight out that way. And this way, by doing it this way, I've got the solder sucker nozzle flush with the board so it seals really well. And I'll heat the pad on the other side, and this one's got a lead in it, so I'll push the lead in, fire the solder sucker, and the hole comes out really nice and clean. And then I'll go to the other end. It's a little harder to get to because, well, I'll have to just do it the other way around because there's too many components on the board, but I can also heat it from the top side of the board. It does the same thing. And there we go. So here's another tip. When you're designing circuit boards, like I did this one, and yeah, by the way, I am the engineer that designed this and the one that goofed up on this. So I did the layout, and what I try to do is have all the text oriented in the same direction, so you can see all the text that's going this way, left, right, is the right side up, so you can read it easily from one position without having to rotate the board around to see everything. And then you notice that some of the text, the designators for the different components are sideways, so I rotate them so that they're always oriented in the same direction as well. And again, you simply change the board orientation, and all your component designators that are on the side are reading the right direction. It's just an easy way to make your board easier to troubleshoot down the road, or when you're assembling it, putting the components in, then you can read the component designators quite easily. Here's another thing that I do, and this might be getting a bit anal as well, but it does help in troubleshooting and just checking your own work when you're done. So I orient the resistors such that the color code bands are read in the same direction as the text that designates that resistor. So on this one here, it's R34, and it's a 22 k ohm resistor. Oh, sorry, I'm watching the board, not the screen. So R34, you can see there, it's a 22 k resistor, red, red, orange, and you see how it's oriented in the same direction as you read, left to right, red, red, orange. Alright, here we are, the first kludge made. And is the camera focusing? Can't really tell. I think it is. Try to keep the glare out of there. So you can see how I've done this. I bent the collector lead over top and put a piece of heat shrink over the lead and soldered it to the pin of this connector. And then this resistor here with a bit of heat shrink over its lead to insulate it from, well, it's pretty much stuck up against those two pins there. So it's probably not going to be a problem, but I put some heat shrink on anyways, and then it's stuck onto this pad over here. And then the other end of it is stuck to this end of the transistor on this piece of trace that I'd cut. Remember, I cut it right there. And I cleaned off the trace and soldered it to there. One more thing that I have to put in is there's another trace, or a jumper has to be put between this pin and that pin. And I'll just use a piece of resistor lead. So there, now it's complete with the extra jumper that I put in here. This one here, I used a piece of cut off resistor lead, and I bent a little loop to go around this post of the connector and held it in place, and then bent the other end around this post here and then just soldered them on. So overall, this little modification, kludge, bodge, whatever you want to call it, it took me 15 or 20 minutes, not counting the time it took me to pull the parts out of my stock, and not counting the time it took me to figure out how to do it. So when this is the second board that I'm doing this to, and the last board, there's only going to be 2 boards modified like this. It took me 2 hours to do the first one, but most of the time was taken up in figuring out how I was going to do it using this kind of thing, printing out the board layout. And this is double, or actually I don't know how many times. This is about 4 times normal size, so I could see what I was doing here. But overall, to do the first one probably took me an hour and a half, and then the second one on here took another half an hour, so it was about 2 hours to do the first change. And if I wasn't shooting a video on this one here, I would be done both of them well within an hour. Doesn't take very long. But again, I've been at this for a long time. It's not that I make a lot of mistakes when I might do design work, but I've had to fix other people's mistakes as well, or do repairs on boards where components have been blown off because of overloads or whatever. Oh, there it is. The second one done. Now, solder is pretty good at holding these parts on the board, but I'm going to add one final touch and goop it up with hot glue. Just put glue in and around all the components. I want to make sure these transistors are well anchored. Make sure it squirts under and around everything. And there we go. Hot glued. Let it cool and then pick off all these little stringy things. But there you have it. How to do a kludge on a circuit board. And you can't even see that anything was wrong from the top side. Hope you got something out of this. Thanks for watching. Catch you another time. Bye for now.